Welcome to another video from Lockdown Electronics with me, Bill. At this time we've got something that's probably quite appropriate for an electronics channel that's based in the Yorkshire Dales, and that's a little bit of veterinary work. I'm sure my English viewers are probably aware of the James Herriot series of stories about a Yorkshire Dales based vet. If you're not familiar with them, if you're perhaps viewing this in the States or you've not come across those, they are legendary stories in the Yorkshire Dales, and a lot of them are based on real life situations. So it's entirely appropriate that we take on some veterinary work, and in this case we've got this this cat, which unfortunately is very sick. It's actually a Radio Shack AM radio with the controls underneath, and belongs to my mother, and I went down to see her for the first time in 18 months because of lockdown, not being able to visit. She lives a few hundred kilometres away, so I went to see her, and she mentioned this radio no longer works, so I've brought it back to see if I can fix it. Don't know whether I can or not, but we'll have a look. I've got a sneaking suspicion it probably isn't anything too complicated, but nonetheless be an interesting project. So ordinarily I'd say let's go and look at this on the bench, but I suspect that what we need to do now with this little critter is we perhaps need to go and take a look on the operating table. Okay, so here's the patient on the operating table. So let's have a look. It's essentially just a stuffed toy with a radio inside a compartment here, and there's just this two controls. That's on, off and volume, and there's a tuning control here, and the radio is inside there. No battery in at the moment, and it's a case of there's a couple of small cross-headed screws down there, so I'm going to remove those screws, and I'm guessing those knobs will come off and I'll be able to then get the radio out. So let surgery commence. Okay, so I've got the radio set up with a PP3 battery just to see how it goes. I've got it turned on, and there's currently nothing obviously coming out of it. I'm just going to check if we have actually got 9 volts. I guess that's going to be a ground there, so that should be that's a good sign. So I'm just going to try there. I'm just wondering how good this battery is. I think what I'm going to do is I've just got to get my bench supply on 9 volts. So on these batteries, that's the positive terminal. So here's bench supply. Let's just pop it onto the bench supply. I'm just going to double check once again on the battery. Yeah, that's definitely positive. Drawing about 80-90 milliamps. Isn't very much wrong with this beastie, is there, by the sound of it? I've just got these controls just pushed on rather than tightening the... Yeah. I think the problem there is it needs a decent battery. While I've got it open though, I'm just going to... There are one or two things that we can check, make sure it's adjusted as well as it can be. So I think it's probably worthwhile doing that now we've diagnosed the fault. Okay, well, I've got the circuit boards removed from the radio. There's just a couple of screws to do that, and although I don't have a schematic and the numbers on the circuit board don't bring anything up on a search engine, it is nonetheless fairly obvious how this radio is configured. So let's just have a look at that, because I think that's quite a nice little exercise in fault finding without having a circuit diagram or a schematic. So what we've got here is this ganged Varicon capacitor, which is both the tuning and the control for the oscillator. We've got a transistor down here which is very close to where the antenna connections are made. So that's probably both oscillator and RF front end, and then we've got 3 IF transformers here with another transistor in between them. So I think it's fairly odds on. This is the IF, and this is probably controls the mixing. Here we've got a glass encapsulated diode. So I'm going to hazard a guess that that's a simple envelope detector. We can ascertain that in a moment on the oscilloscope. We should have AF audio frequency on one side, and we should have intermediate frequency on the other. And if I do check that out, that should also allow me to hopefully work out what the IF frequency of the radio is. And then here we've got another 3 transistors, which think it's a safe bet to assume these are the audio frequency output stages. So what I'm going to do, I'm going to first of all use the oscilloscope to find out which side of this diode is the IF. I suspect, having a quick glance, that it's going to be the bottom side there, which is the most difficult to get to. And we're going to find the sort of the live end of this first IF can, and what I'm going to do is feed the spectrum analyzer tracking generator in there and pick up the output at the end of the IF and see what sort of shape the filter looks like, and we'll see if we can make any kind of improvement at all. If I'm honest, I don't expect to make a great improvement, but while we've got the radio to bits and we've ascertained that it wasn't really broken as such, we might as well see if we can improve the selectivity. Whether we can or not is another matter, but we'll have a go. It's a good exercise in doing that anyway. So what I'm going to do is find the appropriate traces on here, and I'm going to make some temporary soldered attachments to them so that I can feed in and extract a signal while I can keep both hands free. So I'm just going to go and make those soldered connections, and then we'll have a look at the IF stages. Okay, so here you probably can't see it terribly well, apologies for that. Here on the circuit board we've got the detector diode, that I believe to be the IF side, and that one there I believe to be the detected AF side. So yellow trace on the scope I'm going to put onto the first side, and we should be seeing hopefully something that looks like, yeah, that looks suspiciously like AM modulation, so that's a envelope modulated with a carrier. And now what I'm going to do, if I can not block the picture too much with the oscilloscope probes, channel 2, the purple trace, I'm going to put onto the opposite side of that diode, and we should hopefully just see the detected audio. There you go. So if you look at the shape of the modulation envelope of the yellow trace, and it's sort of mimicking what's happening with the purple trace. Obviously, if you could freeze that, it'd probably make more sense. Unfortunately, I've only got 2 hands and I'm using them both, so I can't freeze it, so you'll have to take my word for it. But so we're absolutely sure then that that's the end of the IF there, where the yellow probe is, and the start of the IF obviously is over here at the start of the first can. So now we can carry on and attach some temporary connections so that it can feed in signal from the spectrum analyzer tracking generator, and have a look at what the IF stages are actually doing in terms of filter shape and selectivity, etc. Okay, so I've got 2 wires temporarily soldered here at the start of the IF chain. I've got the tracking generator from the spectrum analyzer being fed in there at the start of the IF, and I've got another temporary connection soldered on here. This is the detector diode is actually between those 2 connections there and there, so I'm on the IF side of the detector diode. So here is the spectrum analyzer plot. I've got the tracking generator running, and I'm just going to turn that over carefully now so that hopefully you can see what I'm going to try and do. I'm going to do my best to keep my fingers out of the picture. So signal's being fed in here, and it's being taken out there back to the spectrum analyzer. And so what you can currently see is the peak there just slightly above the 455 kilohertz IF center frequency, but quite a reasonable sort of shape, and the full width of the display there is 100 kilohertz, so 10 kilohertz per division. So as you can see, most of that there is within about 30, 35, 40 kilohertz ish, something like that. So it's pretty reasonable for the medium wave band. So what I am going to try and do is just center up that IF frequency if I possibly can. You probably notice when I touch the board it has some effect on the frequency. So I'm going to first of all try this first one. I suspect this won't do much. I suspect that's going to be the mixer coming from the front end, so I doubt that's going to do very much for the shape of the graph. No, that's pretty much, maybe a little tiny bit, but really not very much at all. I do however expect this one to have a bigger impact, so we'll try first of all moving that one, and I didn't move that very much, and as you can see I've now got a much sharper peak. So it's a little bit off the 455, but I'm not too concerned about that as long as it's nice and selective. So second one's bringing it back a little bit. In fact, if anything, I've got it slightly narrower. Just losing a little bit of sensitivity there. So I'm going to go back to this yellow one and see if I can just put that back on the 455, and then I'll be more than happy with that result. It really is very, very fine adjustment. There we go. I think that's pretty good really for a little AM radio. So that was signalling there through the IF chain being taken off there, and we've now got a pretty good shape there to the filter. So we'll have to see how that sounds now I've done all that. Okay, so I've got the radio back in its case now, and the improvement in the shape of the IF filter was gained using these two IF cans, and they've got the IF amplification transistor in between them. Now I did initially try this can and also these two trimmers. That's the mixer, and these are the oscillator and the RF front end trimmers. So what I want to try and do, the radio is working and receiving okay, but I'm just going to make absolutely sure that it's as sensitive as I can reasonably get it. So these two crocodile clips here, or alligator clips depending which one you fancy, are attached to my analog signal generator. I've got the radio tuned roughly to the middle of the range, and I've found that frequency using the signal generator. So I'm going to just put a 1 kilohertz tone on, which you can probably hear there, and there isn't very much. The coupling essentially is coming from the tone, is just leaking across from those bulldog clips, and I've got a very simple but effective way of attenuating the signal. If I move the radio away, it gets less. So what I'm going to just do now is just check that I really have got the best adjustment I can on these cans. So I'm going to position it there, and I'm just going to see how this mixer IF can is working. Apologies if you can't see that as well as perhaps you might. Yeah, got ever such a slight increase in volume there, but when you take the tool out it's not quite so good. So I'm just going to move that away a bit, get a weaker signal. You can see it is quite fussy where that is, and I've certainly moved that more than that when I was looking at the IF earlier. So that's about the best I'm going to get that. I'm just going to check these two trimmers. One will be the oscillator and one will be the IF front end. Again, there's very, very fine adjustments on here. That's about as good as I'm going to get that one. yeah, definitely got a bit of an improvement on that one. So I think that's probably about as sensitive as it's going to get. So I'll just switch the signal generator off and tune to a station, hopefully not with any music so I don't get a copyright strike. Yep, so that seems to be working absolutely fine. So that's good. Next thing I want to do, I'm running off the bench power supply on 9 volts and it's drawing about roughly 8 milliamps. If I really turn that up, find a loud station, let's just see what she's like on a left. I literally would like music, but I can't find any. If what's being planned here doesn't turn you on, then you need to see a doctor. Keep it tuned to TalkSport for authentic sound, and I'm certain that atmosphere. So it's drawing about 8 milliamps according to my power supply. I'm just going to pop the meter in series with that, as the power supply display isn't maybe as accurate as it might be. Just want to see exactly how much current it's drawing, so I'll just connect that up and come back. Okay, so if I just so radio's off. I've got the milliamp meter in series now with the supply, so I'll just switch on and turn up the volume. And yeah, it's drawing about about maybe 13 milliamps, 12 milliamps, something like that. Just turn that noise off. So 12 milliamps and capacity of a PP3 zinc carbon PP3 is about 400 milliamp hours, I think. So I would imagine that's going to be all right. So next thing I'm going to do is actually get the one I tried it on initially when you saw me at the start. It isn't a particularly good battery, so I'm going to get a better one now and see if the radio's okay just on a battery. Okay, so we've just closed the patient up. I was hoping I might have a glamorous assistant to help me close up the patient for me, but unfortunately I don't have one, so I've done it myself. So as you can see, the radio just tucks inside the body of the animal. Battery tucks in there too, and we've got volume and tuning, so I've got it tuned to a station. So if I just turn that up, it's got a ferrite rod antenna, so the position of the animal obviously affects the reception quality. Going to move off that music in case I get into trouble. There's a bit of a talk station. The adjustment on that is so critical to actually net on to something, but that's just a function of the simplicity of the radio. So when the little critter wakes up from the anaesthetic, hopefully she's going to be back in full working order. Oh, well, I'm very pleased to say that the patient's now fully awake and seems quite lively. So, steady. So I think all good there. I'm sure that Mr. Farnan would be very pleased indeed with my work there. We've managed to restore the patient fully to health. Wasn't too serious a fault in the end, but hopefully it's actually going to have a better quality of life now than perhaps she did before. Thanks very much for watching. Hope you've enjoyed the video, and even though the fault was simple, it's given us a chance to look at how you can diagnose a fault even without a circuit diagram and make some improvements. Thumbs up if you like it. If you don't, you can click the thumbs down. Either way, thanks very much for watching. Always appreciate that. Be great if you could subscribe, and if you like the channel, please let others know about it. Thanks very much. See you on the next one.